The remarkable journey to discovering alien worlds. Just about 30 years ago, we didn't have any scientific proof of a planet outside our solar system. Today, the universe feels closer than ever, thanks to breathtaking advances in technology and the relentless pursuit of scientific discovery. Over 5,300 exoplanets, alien worlds orbiting distant stars, have been identified. Each one holds secrets waiting to be uncovered. At the beginning of this groundbreaking journey, most of the planets discovered were massive gas giants like Jupiter and Saturn. But as our telescopes improved and our techniques refined, we began uncovering smaller, rocky planets resembling Earth. More than 50 such planets with masses similar to Earth have been identified, and over 800 worlds with radii less than half that of Earth have also been catalogued. While many of these planets lie outside the habitable zone, the region around a star where conditions might support liquid water and potentially life, a handful of them have sparked excitement in the scientific community. Our exploration is unveiling planetary systems with not just one but multiple worlds that could sustain life. And one such system is remarkably close to Earth. A closer look at Gliese 667, a triple star system. Situated just 23 light-years away in the constellation of Scorpius lies the fascinating Gliese 6667 system, a trio of stars orbiting one another in a cosmic ballet. Among these stars, the smallest and faintest, Gliese 667c, has captivated astronomers worldwide. This M-type red dwarf harbors a planetary system rich in diversity, including at least 3 and possibly up to 4 potentially habitable worlds. Gliese 667c stands apart from its 2 brighter siblings, Gliese 667a and Gliese 667b, both K-type orange-red dwarfs. While A and B are larger and farther apart, C is a humble red dwarf with a mass and radius only a third that of our Sun. Its faint glow, with just 1.4% of the Sun's luminosity, creates a cozy habitable zone much closer to the star, perfectly suited for rocky planets. The star and its remarkable planets. At first, scientists believed Gliese 667c hosted just 3 planets. But further analysis revealed a more crowded system, potentially home to 6 or even 7 exoplanets. Among these, Gliese 67cc, CE, CF, and possibly CD stand out as candidates for habitability. What is a super-Earth? Many of the planets in the Gliese 667 system fall into the category of super-Earths. This term describes planets that are larger and more massive than Earth, but significantly smaller than gas giants like Neptune or Jupiter. These worlds could consist of rocky surfaces, icy layers, or even a mixture of both. Depending on their atmospheres, they might harbor conditions suitable for various forms of life. The jewel of the system, Gliese 667cc. Among all the planets in this system, Gliese 667cc is often referred to as the holy grail of exoplanets. This rocky world orbits within the inner edge of its star's habitable zone. With a mass approximately 3.8 times that of Earth and a radius 1.8 times larger, CC completes a full orbit around its parent star in just 28 Earth days. What makes this planet particularly intriguing is its Earth Similarity Index of 0.85, a score that indicates its potential to support conditions resembling those on our planet. However, living on Gliese 667cc would be far from familiar. Its proximity to the red dwarf means it likely experiences tidal locking, where one side perpetually faces the star, bathed in eternal daylight, while the other side remains in permanent darkness. The temperature differences between these 2 hemispheres could create extreme weather patterns, but if Gliese 667cc has an atmosphere similar to Earth's, it might distribute heat more evenly. This could allow for a more temperate twilight zone between the day and night sides, where conditions could support life. The planet receives about 10% less light than Earth does from the Sun. But because most of this light is infrared, the planet absorbs energy more efficiently, potentially creating a climate similar to ours, if it has a suitable atmosphere. Without it, however, the surface could be a barren wasteland, frozen in eternal extremes. The other promising worlds, CE, CF, and possibly CD beyond Gliese 67cc are its siblings, CE and CF. These planets are slightly farther from their parent star but still within the habitable zone. Both have masses around 2.7 times that of Earth and radii approximately 1.45 times larger. These characteristics make them super-Earths as well. While they may receive less stellar energy, a thick atmosphere could help trap heat and create conditions favorable for liquid water. If such atmospheres exist, these planets could support climates vastly different from CC, possibly resembling icy moons like Europa or Enceladus in our solar system. There's also the mysterious Gliese 667 CD, whose orbit is less certain. If confirmed within the habitable zone, CD could join the ranks of potentially habitable worlds in this already extraordinary system. Challenges of habitability. Although the Gliese 667 system presents exciting possibilities, there are challenges to consider. One major issue is the star itself. M-type red dwarfs are known for their flares, intense bursts of radiation that can strip away atmospheres and bombard planetary surfaces with harmful particles. Gliese 667c is no exception. Another challenge lies in the gravitational pull of super-Earths, like Gliese 667cc. With a mass nearly 4 times that of Earth, the planet's gravity would make everything feel significantly heavier. A 75-kilogram, 165-pound person would weigh around 120 kilograms, 265 pounds on CC. Moving and even standing would require much more effort, and any life forms on such a planet would likely evolve differently to adapt to these conditions. Additionally, higher gravity allows planets to retain denser atmospheres. While this could protect against radiation, it might also create crushing surface pressures, especially if the atmosphere is more like Venus than Earth. The bigger picture. What Gliese 667 teaches us. The discovery of multiple potentially habitable planets in a single system is a reminder of the incredible diversity of planetary systems in our galaxy. M-type stars like Gliese 667c are the most common type of star in the Milky Way, comprising over 70% of all stars in our cosmic neighborhood. This means there could be countless systems with similar configurations, each holding the promise of new Earth-like worlds. Why M-dwarf stars matter? M-dwarf stars are small, dim, and long-lived. They burn their fuel so slowly that they can outlive many larger stars, providing stable environments for billions of years. This stability makes them prime candidates for hosting habitable planets. However, the compact nature of their habitable zones means that planets must orbit very close to the star, increasing their exposure to stellar activity. Despite these challenges, planets around M-dwarfs remain some of the most promising targets for future exploration. What lies ahead for Gliese 667 and beyond? As astronomers continue to study the Gliese 67 system, new discoveries could reshape our understanding of habitability. Future telescopes like the James Webb Space Telescope (JWST) and the Extremely Large Telescope (ELT) will be able to analyze the atmospheres of these planets in unprecedented detail. By detecting chemical signatures such as oxygen, methane, and water vapor, scientists could determine whether life might exist on these distant worlds. What if life exists? If life does exist on Gliese 667 CC, CE, or CF, it would likely look very different from anything we know. These planets' unique environments, ranging from extreme gravity to constant exposure to infrared light, could shape life forms adapted to conditions we can only imagine. Creatures on Gliese 667 CC might thrive in perpetual twilight, while those on CF could be built to withstand icy conditions. The cosmic implications. Discovering life, or even just habitability, on planets like those in the Gliese 667 system would fundamentally change how we view our place in the universe. It would suggest that life isn't just an Earth phenomenon, but a common outcome of the right conditions. Instead of a lonely speck in a vast cosmic ocean, we might find ourselves part of a galaxy teeming with possibilities. Your turn. Explore the cosmos with us. What star system would you like to hear about next? Drop your suggestions in the comments below, and don't forget to subscribe to KM Celestial Journey for more thrilling explorations of our universe. If you enjoyed this journey, click the super thanks button to show your support. Together, let's uncover the next big discovery in the cosmos. Thanks for watching.